Thank you, ma'am. Good morning, esteemed dignitaries, honored guests, respected faculty members, and dear participants. It's a great honor and privilege to introduce our esteemed guest for today, Dr. Mohammad Riyath, a distinguished academician, researcher, and thought leader in the field of accounting and finance. Dr. Riyath currently serves as a senior lecturer in the Department of Accountancy and Finance at the Faculty of Management and Commerce, Southeastern University of Sri Lanka. With over 15 years of research experience spanning academia, research, and industry, he has made remarkable contributions to financial research, higher education, and institutional development. Dr. Riyath is a fellow member of the Institute of Certified Management Accountants of Sri Lanka and holds prestigious certifications in IBM, data analytics, and Google business intelligence, reflecting his strong expertise in integrating finance with modern data-driven technologies. Alongside his teaching responsibilities, he plays a significant role in academic leadership as the Deputy Director, Training, Research and Development. He actively contributes to research, supervision, quality assurance, and curriculum development, and has guided numerous post-graduation students and shaping future scholars and professionals. His research profile is truly impressive, with numerous publications in reputed international journals and book chapters published by globally recognized publishers such as Emerald, Wiley, and IGI Global. His research areas include financial markets, corporate finance, fintech, sustainability, and emerging technologies in finance. Dr. Riyath has received several prestigious awards, including Vice Chancellor Award for Outstanding Senior Researcher in 2025, multiple Best Paper Awards, and Best Presenter recognition at international conference. He is also an inspiring speaker who has delivered keynote addresses and invited talks at various international forums, financial awareness programs, and student engagement initiatives, thereby bridging the gap between academia and industry. Today, we are truly fortunate to have such an accomplished scholar and visionary leaders among us. So without any further delay, I warmly welcome Dr. Riyath sir and invite him to share his valuable insights with us, sir. Thank you.
Okay, thank you very much, Dr. Premalada, for
Thank you, sir.
inviting me and give me this opportunity to share some of my knowledge. And also, I extend my gratitude and to the administrative officers of T. John's College, a group of institutions, and uh, and the faculty members of Department Studies and researchers and IQSC. Let me share my screen.
Thank you, sir.
Sure. I can share screen. Okay. I hope you can share my screen. Okay. Let's move to the session. The topic of the session is AI integrated bibliometric analysis for identifying research gaps. Here we are going to talk two things. One is AI, artificial intelligence. Now the era has changed. Everybody talk about AI. Some of them think AI is a co-worker. Some of them AI is a research assistant. Some of them AI can do whatever we want. So there are different perceptions. And the most of you, everybody of you are waiting here and joining here to find out or identify research gaps to be published in good journals, Q1, Q2 journals. And some of you need research gaps for applying PhDs and higher studies. People are right have different idea, but some idea could work, some are not. Here, the identifying research gap, filling research gap, is a key of scientific research and the core of valid research proposal. Here we will discuss that part with the integration of AI, and we are employing a proof method, a scientific method rather than biased method, that is bibliometric analysis. It's a proven method for identifying research gaps. I'm not much discuss about the descriptive things. Some you may see a lot of videos in YouTube's, and you may attend many webinars or workshop on uh, working with some bibliometric analysis softwares like R, Biblioshiny, VOSviewer. So I'm not going to discuss in detail about that sort of things. My focus will be on spotting research gaps. Meanwhile, we are getting help from artificial intelligence, especially a well-known AI, ChatGPT. Right. Now, let's move that AI integrated bibliometric analysis for identifying research gaps, the cartography of science. Why do we need bibliometric analysis? And how do map the frontier human knowledge from scratch? Right. Earlier, right before the introduction of bibliometric analysis and other sort of systematic literature reviews, what people do, what people did actually, they read papers, they collect papers, right? They meet supervisor, the students, the candidate, express the idea, their likes and dislikes, and they are in the domain and just they find some of the papers, say 6 to 50 to 60 papers, read those papers, and they process using here their brain. But the thing is, the human brain has capability limitations, so it can process very few papers. Even though the human read many papers, they can keep the ideas in the brain, right, in for few months, and uh, it takes a lot of time to process them. But when we look at the global scenario, the actual thing, every month or every year, publishers are publishing millions of research. It grows exponentially day by day. Every day, publish new articles. Sometimes we find a gap. We are trying to work out. We spend a lot of time and is ready to submit the paper, but unfortunately or fortunately, we see the papers, we see the titles that we are intended to do that. So we whole idea got collapsed. Sometimes, not most of the times, we write the papers. We spend a lot of our effort. We spend a lot of time, and we put our effort maximum. And we write the papers. We send the papers to the journals. We got reject desk rejections. Desk reject. Most of the time, we got desk rejections without moving to the reviewers. So it's got frustrating for researchers, especially uh, South Asian researchers. Right. So due to this, let us move some of the paradigm shift from reading to mapping. So we can understand that there are millions of research in our field. Reading all of that paper is impractical. So manual method will not work. And there's a method. There's a scientific proven method, an efficient method that can accommodate thousands of papers. Let's see. Let's do some comparisons. Manual methods is a linear. So we read the paper by paper and subject to unconscious selection biases and cognitive limit. Say, Mr. X is my supervisor. I'm going to do, if I want to do research under his supervision, I the candidate may read or give more preference on to the papers written by his supervisor X. So that's a bias. Actually, they are not finding the gap, actual gap. Rather, they wanted to satisfy the supervisor, or they wanted to satisfy the journal editor. It's a bias. The outcome is the subjective feeling of research gap. So subjective method of filling research gap is a biased one, so it will not work most of the time. Alternative for this, as a solution, networked algorithmic evaluation of metadata, right? So you might heard about the databases, Scopus, Web of Science. So why all peoples, when they are submitting the papers, they are concerned about whether it's index paper or not index paper? Why they are worrying? Why do they are thinking about that? Why do they pay more attention on that? So it's a globally accepted metadata platform, it's a database. Those are the database. The strength of this uh, bibliometric method, mathematical and objective statistical evaluation at massive scale. The outcome is your research gaps is demonstrable, data backed topological mapping. So core definition of bibliometric analysis. Bibliometric turns literature into data by algorithmically analyzing citation patterns and keyword frequencies. It reveals hidden structure and evaluation of research field. Someone's mic is okay. There are four pillars of bibliometric value. So we use bibliometric analysis for four purposes. Number one, measure impact. People are published papers, authors publish papers, journals publish papers, people rank the authors and the journals. There are prestigious journals, top tier journals, top 2% of researchers. These are what? Impact of authors, impact of journals, impact of articles. So the seminal paper, right? Seminal author, the breakthrough paper. So they did an impact. The bibliometric analysis is a tool to measure the impact. It is to identify seminal works, leading authors objectively using statistical metrics rather than assumptions. Same, we know that papers, we know that a particular author, then we announce he is the prominent author. The research, we may publish one research article on that journal, so it's a seminal paper. The journal is a seminal top tier journals, no. So those are biased one. Here it's a concrete mathematical and objective method of measuring the impact. From this analysis, we can say that so this is impactful paper, impactful author, impactful journal. Spot the trend. People, right? You may heard this instruction or advice from your supervisor or colleagues. When you select a paper, we have to do research on trending areas, right? Trending topic. That's why the people says. So what is the trending topic? If I ask this question, everybody of you telling, sir, machine learning, artificial intelligence. These are the topics, trending topics, because everybody talk about. But actually, when we do research papers, we have to find the trending areas scientifically and mathematically. So there are a lot of methods in bibliometric analysis that visualize temporal evaluation of themes to see exactly which topics are rising, peaking, or falling over time, which areas are outdated, which area is booming, which area got measured at peaking. So these things we need, and map collaborations. Right? If you plan to do a research with and you don't know to whom you are working with, who fit with your interest, and which university is more suitable to you. If you want to find a co-workers, co-author to collaborate with, who is the suitable one? To find out these things, this bibliometric analysis will help you. Map collaboration. It reveals hidden social network, institutional partnership, universities, research institutes, and cross-border knowledge diplomacy. And the fourth one, our our focus is detect gap. Transition from assuming a white space existing to proving with structural data and network isolations. Right? So our focus on, right, detecting gap. What are the ways of spotting that research gaps? For that, bibliometric analysis will help us. Let's see, there are four. Let's discuss a little bit. Concept number one, performance analysis. Performance. Which author perform well? Which journals publish most of the article on this domain? And which country or which university perform well? Which paper got made some influences? It's called uh, right. It's called what? It's called. It's a very well known seminal paper, right? Here, the total publications, an author, how many papers he got published, or the paper, how many citation it got, and H indexes. So it measures the impact of the authors. And beyond that, there are two main theories. There are two laws: the laws of the landscape in the performance analysis of authors, not authors actually, performance analysis of the journals. Bradford's law measures of the concentration of literature, identifying the core journals versus peripheral scatters. Why do we need this kind of analysis? For example, you have written a paper and you have to decide to which journal you are going to submit this paper. You have to find the journals, you have to target the journals which are most suitable for your topic, the scope, right? Your paper is very much, right? It's very good paper, but once you submit the paper to a journal, within 1 or 2 weeks, you got desk rejection decision. It doesn't mean your paper has no value. Most of the time, people submit the paper, good journals, good papers to wrong journals. They are out of scope. So bibliometric analysis is very important to find out what is the correct journal to be submit. So the paper has to be submitted to a correct right journals. And if you plan to submit on that journals, and you have to find out the seminal papers published by such journals. If you are not cite that journals, the journal, right, implicitly come to the conclusion that they are not following our journals. They are not respect our journals. They are not following the what we have published recently. Same thing for the authors. If you fail to cite seminal authors on that paper, then paper got rejected. So there are two laws, Bradford laws. So Bradford laws will find the core journals in the topic. And Lotk's law, so it evaluates frequency distribution of scientific productivity among authors. Number two is called scientific mapping. We will see three different maps in the bibliometric analysis, especially the VOSviewer. People can generate nice, wonderful, very attractive, colorful networks, but the people don't know what does it mean. They don't know how to interpret. And say if you generate this kind of network, so you can see the bubbles. So this bubble is called knots. node, N-O-D, nodes. The node representing items. If you do the author network analysis or citation, co-citation analysis or bibliometric coupling analysis or keyword analysis, mapping analysis, so this node represent the respective things. And some of the bubbles are larger, some are little, small. The size of the bubble represent the volume. Sometimes a paper got many citations, so large bubble. A paper got small citations, small. And like frequency or frequency of keywords, some keywords occurs many times, so that keywords, the size of the bubble is large. Some keywords are getting a few number of frequencies occurrences, so that time is small likewise. And you see the edge, so there are some neurals connections. It's called edges representing relationships, citation, co-authorship, like that. So you can see the thickness. There are different thicknesses here. Yeah, thickness is high. So here this is right, less thickness. So the strength of connections, the thickness represents the connections, the strongness of connection. And you see, this is one color, this is another color. The color represents clusters, right? Cluster groups. Cluster represent thematic grouping, so automatically identified by mapping algorithms. Architecture of connections. There are, right, we are going to deal with three main things: authorship analysis, co-authorship analysis, covert or keyword analysis, and cited analysis. Why do we need this? Co-authorship analysis, what it maps: social network and institutional collaboration. Which institute or which authors work closely with whom? Why do we do this? Finding invisible colleges, global partnership, and key institutional players. If you want to if you want to find a supervisor, or if you want to find a university appropriate for your research topic, this will help you. And keyword analysis is a conceptual structure of the field. It's most important, a very important one, to find out research gap, to find out to finalize the topic. What it maps: word keyword analysis, the conceptual structure of the field, best for identifying dominant themes for research, tracking concept evaluation, and discovering interdisciplinary crossover. In simple terms, research gaps. And citation analysis, right? You when you write the paper, right, at the bottom of the paper, at the last pages, you can see that your references. Some people thinks it's just references. No, the bibliometric analysis, the key, right, the key is citations, references is the key. What it maps: citation analysis, direct influence, and scholarly impact. It is best for finding the most highly impactful papers and tracing new ideas. So that is the thing. The new ideas are transmitted. Research gap, future research directions. Right. There are two things. Many people got confused on this, and many of the researchers don't know why we are using this. Co-citation analysis, bibliometric analysis. But the purpose of doing this? People just do analysis on the keyword mapping, or keyword relationship. They just presenting this is my research gap of future research directions, but actually not. There's a scientific method, right? There are two things: co-citation analysis. Co-citation mean, for example, this is your paper, right? This is your paper, and paper A, you cite it on your paper. paper B cited on a paper. So these two papers, right, A and B, call them co-citation. Co-citation, right? And here, right, here, paper A, right, here, this one, bibliometric coupling. Paper A cited paper C. Paper B cited paper C, right? Then, sorry. So then these two papers called bibliometric coupling, right? What the purpose of doing this? Right, listen very carefully. This is the paper. You can see at the bottom of the paper, end of the paper, you can see the reference list. Then paper A and B are cited in one paper. So that is co-citation analysis. Bibliometric coupling is different. Paper A cited this paper, and this paper also cited this paper, right? So this is bibliometric coupling. The purpose of doing this co-citation analysis is used is used to find the foundational knowledge, the past. It's a backward looking, what happened in the past. It reveals foundational theories and intellectual pillars, right? The many students, when they are doing research, they want to work with correct theories. They want to use the correct theories as a lens. But what the people do is just uh, ask the ChatGPT. So this is my topic. What is the relevant theory for this paper, this topic? Then the ChatGPT or AI will give you some of the theories. People use that theory. No, there's a way of finding the theory, relevant theory. For that, we have to do a co-citation analysis. Look at the paper. At the end, you can see the references, and we can look at that there are many papers. Those are foundation. Your paper is developed based on that references. So it gives you a foundational knowledge, foundational theory. So mechanism is two old papers are cited together in a new paper. It's old, right? Backward things. Talk about the past. And on the other hand, bibliometric coupling, a paper cited one paper. Another paper cited the same paper. So this is it's a current, right? Not the future, it's a current. Two documents are coupled if they share a common reference. Paper A, right? You see the paper A cited a paper, and paper B somewhere cited the same paper. So those are bibliometric coupling. So what the things? So forward looking, it maps the current frontier of active research. This is the trending topic, trending research. Now here, this is past. Co-citation analysis deal about the past, and bibliometric coupling will give you hints about what's the trending research areas, right? Trending papers. So we have to use this co-citation analysis and bibliometric coupling at the same time. Synthesis not. Comparing these two maps reveals if the current frontier is drifting away from its theoretical foundation without establishing one, right? Without theory, you can't develop a new conceptual framework, right? So the conceptual frameworks are developed based on the theories. So that theories you can identify from co-citation analysis. You can develop your conceptual framework using bibliometric coupling. And also you can see this kind of heat maps, density heat maps. What are the use of this? So then the density heat map. So you can see the red zones, yellow zone, and blue zones. Red represent the heat, hot, and the bluish zone are right. So called so holes. So those are no densities. So red zone means those are saturated. They are heavily discussed topics. Heavily discussed. Already got developed, saturated. It's very hard to find research gaps on that areas. We need to refine. We can add some values, but we can develop from the scratch. Saturated zone, the red and yellow, deeply investigated, highly comparative topics. So these things may be discussed in their motor themes. Cold zone, so blue, structural holes and underexplored territories. So if you want to work, right, so these are the areas. Well, those are not sufficiently matured. There are a lot of research holes. And the temporal overlay, right, throughout the period, right, the period, you can see the color, the range, that is 19, 20, 21, 22, right, it's a color. You see the yellow, the latest one, those are current trending things, right? The temporal overlay, color gradient, blue equal historical foundation, the old ones, right? The blue area, the blue nodes, very older ones, historical foundation. Yellow and greens are current hot trends, current topics. Diagnostic value identifies temporal gaps where a major historical foundation lacks connection to current research frontier. So we have discussed all fundamentals. Now we are the point, the ultimate goal, the pinpoint in the research gap. So the wall is an existing theory, existing research, existing knowledge, literature. You have to write paper, you have to do research to fill the research gap. The mindset shift, move from descriptive, this means summarizing what has been done, these things cannot be done, so I'm going to do this. No, we have to find this research hole, the gaps in the literature in scientific way, right? Moving from descriptive to a diagnostic way, proving, providing what is functionally missing. You have to scientifically prove what is missing in the literature and redefining the gap, right? We have to precisely define this is a research gap. A research gap is a functional deficiency in the literature, a hole in the scholarly wall where existing theories or methods fail. So you have to spot that point, spot that hole. Right. For this, bibliometric analysis will help you. That's the
Guys, don't use
advantage
your
of
mobiles.
that's the
Don't
advantage
use your
of
mobiles.
excuse me. Okay. Bibliometric transitions gap identification from subjective feeling to demonstrable, scoreable proof guarantees high information gain for the field. Right? If you use bibliometric analysis in a proper way, you
What is
can,
it? Replacement. Replacement
yeah,
training is going on. Okay.
right. Now we come to the point as blueprint of knowledge. So catalog guide to bibliometric mapping, gap discovery, creating the tragedy of science. So this is the thing. What people do is they access the scopus of web of science and they download the data, right? It's an ocean of knowledge, and just they put into the Biblioshiny or VOSviewer and do the analysis and just report that we have found the research gap. It's it is totally make mess. It's totally uh, wrong method. So you have to be aware of that. Here, in the Scopus and Web of Science, we can see the ocean of knowledge, and you have to, right, you have to pick, you have to collect the things, the metadata from those databases, and you have to strictly follow the Prisma model, preferred report information items for systematic and systematic review and meta-analysis, or SPA model for systematic literature review. For this, these are the you that you have to define the boundaries. We are going to work on this using the Prisma method or SPA for SLR method, and you can use some AI. Right here, you can use AI for rapid, unbiased inclusion and exclusion criteria. Right, then you finally come up with structured corpus. So these are the final data set ready for analysis. And some people ask, why not Google Scholar? Why can't we use Google Scholar? So why we always depends on Web of Science or Scopus? So Web of Science and Scopus are well-structured databases, but Google Scholar, so there are some things. So it lacks rigorous curations, creating noisy environment of duplicates, uneditable formats, and unreliable entries. Some people manipulate some citations. True mapping requires the structured metadata for curated databases. That's why we are relying on Web of Science and Scopus. Here, combining the master databases. Here, Scopus and Web of Science. When we get the data from Scopus, prefer use a CSV data, CSV file, and the strength is broad coverage, modern literature. And the Web of Science, when you export data from the Web of Science, you can use BibTeX format, and the strength is the deep historical citation and data. So there are two things. It has pros and cons, advantages and disadvantages. So better always the good idea to merge two data sets, Scopus and Web of Science. To combine these two databases, we can use RStudio, right, using R language, bibliometric engines, the comprehensive imperatives. Relying on single database risk structural blindness. Combining Scopus and Web of Science mitigates indexing biases and captures a multi-phased nature of the scientific discourse. There, another one is we spend, right, as I told you earlier, people directly input, right, whatever they import from the Web of Science or Scopus, they directly insert into the Web of Science or into the VOSviewer or Biblioshiny without refining the raw data. It misleads. So the 20% is what? Just to find literature gap and research gap and impact analysis, performance analysis. Those are only 20%. 80% of the time in bibliometric analysis we spend for cleaning the data, for purifying the data, refining the data. So very careful. Many people didn't do that. Bibliometric data is inherently dirty even though you are downloaded from Web of Science or Scopus. Imprecisable string errors, false aggregations, and changing database indexing rules will severely distort your final network topology. Entire research gap finding, entire direction for future research, everything got wrong. Impactful paper, impactful research, impactful author, seminal paper, everything got wrong, right? So standard graphical user interface tools cannot fix this. So it takes a lot of time. For that, we can integrate some AI automations. The two-stage cleaning protocol. Stage one, so we have a big number of data, a large volume of data, right? So both automation, we can use automation Use algorithms to calculate similarity weights. Set high threshold greater than or equal to 0.6 to flag likely duplicates without overwhelming manual review. So first we can do some automations. We can apply some machine learning algorithms. It detects duplications and remove citations and pattern, right, and standard patterns. After that, the stage 2, we do narrow targeting. So here manually screen top 1% of the important notes, important papers, important journals, and important keywords. So we have to work out. We have to select top 1%. That 1% will give you the right directions. So be careful on that. Authors with 3 or more publications, highly cited references, right? Fixing errors are dramatically stabilizes the network. So 80% of the time we spend so that we can understand what is the importance of cleaning the data set. For example, you see uh, an author in one paper, he has written his name Levinthal Daniel is in one paper. On another paper, he write his name Levinthal Dan. Here Daniel, so Dan. In another paper, he writes Levinthal, Daniel A dot. Sometimes they put full stop, sometimes comma, sometimes semicolon. But here all these authors, all these different narratives, the labels referring one author. You see, in a university ranking, the ranking of authors in university, a particular author may have 50 publications, but in the but he not rank at the top in the university ranking because the using the Scopus or Web of Science. Even though he publishes 50 papers, it shows only 20 or 30 papers. Why is that? The thing is this: his name appeared 2 times in two different manner. Likewise here, Daniel, Dan. So it misleads here 50 total 50 papers and scattered as a 20 and 30. Then he goes wrong, far away. So it's mislead. So careful aggregation is important. Disambiguation filter. Here what we have to do is the filter. We have to do these things first AI or automation methods or manual method. We have to refine like this. We have to refine. So Levinthal Dan or Daniel is referring this author. Then writes a clean. This is a clean one. So in the network diagram or thematic map analysis, so these things may clearly so without any errors. So the data cleaning is important. Methodologically coded. So thesaurus also we need thesaurus synonyms. Sometimes here artificial intelligence. Some authors write artificial intelligence. Some authors write AI. Some authors write artificial dash intelligence. Some authors write in different ways. Some of the capital AI, some of the small AI, right? So we have to instruct the software that these are referring same word. Like that we have to do filter. Now here come to the point, bibliometrics or Biblioshiny and the VOSviewer, we have to use these two things, two softwares at once, right? Here are is work as data analyst, VOSviewer as a topographer, right? They are Biblioshiny. The R is expert in doing analysis, but VOSviewer is good at mapping the network. So we use R for performance analysis and trend mapping. For research gap identification, we need the thematic map, 2x2 grid. So this is very important to find out the research gap. And in the VOSviewer, we need 3, right? We need three maps: network analysis, co-citation analysis, bibliometric coupling analysis, and keyword analysis. These three are important. When we find the research gap, we have to do all these things together. This time, the role of AI is essential. Here, remember again, we do co-citation analysis to find the foundations, and bibliometric coupling analysis to find the current state of the research, and finally covert or keyword analysis to find out the map the conceptual frontiers, highlighting emerging terminologies and future interactions. Right. The gap discovery engine. Bibliometrics do not merely the art of summarizing what has been done. It is mathematical tool for providing what hasn't been done. By overlaying systematic logic into our thematic and nonological maps, we can translate visual topologies directly into rigorous, defensible research gaps. The shape of networks are map of human ignorance and future opportunity for research. Here we are going to do two things. One is Biblioshiny and VOSviewer. I have already installed these two things. This is VOSviewer, and I already installed library, bibliometrics library, and I'm start Biblioshiny, so you can see it later. Right. So here Scopus we will see the things. So we will do it, and here we are going to use two things: Biblioshiny R and VOSviewer. Here there is steps. The evidence engine. We have to provide the research gap. We have to give the validated gap as an evidence with evidence. Number one, phase one, base framework. The determining strategic position using cluster, centrality, and density on the thematic map. So we in the phase one we will use the thematic map in Biblioshiny, and then the second page we have to move to the VOSviewer is triangulating evidence. In the Biblioshiny we will, right, in thematic map we will find, right, the preliminary evidences, then we have to prove as these are the concrete evidences. Triangulating evidence, page number 2, layers in network data, keyword co-occurrences, bibliometric coupling, and co-citation analysis foundation. So we merge two, and in the page 3, synthesize, construct the gap using quadrant logic, formulate defensible future research directions. Finally, we do validation, stress test the gap using evidence strength scales and rigorous uh, a diagnostic checklist. Right here, this is the thematic map, and then we use VOSviewer. Uh, so we will do it. We will do it as an example. In the case bibliometric blueprint, step by step guide to preliminary stages of bibliometric analysis. Here, my research area, right? My topic first. We are not define the topic first. We have to define our research area. Here, I decided I'm going to do research on accounting. My field is in accounting, right? Especially narrative reporting with regard to annual report and financial report, that kind of disclosure, corporate disclosure. I'm going to investigate carbon emissions, carbon, greenhouse gas accounting, especially here scope 1, 2, 3 emissions, carbon footprint tracking, emission accounting. Those are the key terms. And digital transformation. I tried to combine carbon accounting disclosure, technology transformation, especially how artificial intelligence and machine learning, blockchain and big data, digital platforms will enhance this carbon accounting disclosure. It's coming under ESG, environmental, social, and governance reporting and framework, TCFD, ISSB, IFRS S2, CSRD, GRI, SASB, sustainability governance. Those are main things, main standards, mainly use the keywords in their not keywords. Those are the key terms when we are talking about ESG reporting framework. Here, right, in the Scopus, I have now access on Scopus as you give me. Here there are three domains. Number one, carbon accounting, right? Greenhouse account, and right, we limit digital technologies, artificial intelligence, blockchain, and third domain is a climate domain, climate change, net zero carbon, and so on. So here now onwards, we will use the ChatGPT and AI for bibliometric analysis. So everybody have that ChatGPT, and there are some GPTs inside or ChatGPT. Here you can see called GPTs, and you can search here bibliometrics, biblio. You can see yes here bibliometric buddy. So you can use this. It will help you in the bibliometric analysis and find research gaps. So now you can see this, and I have already prepared my prompt. Here, this is my prompt. I am conducting a bibliometric analysis on the research on the topic. Here, carbon accounting, technology transformation, and climate change. Please generate Scopus research query for this topic. Requirements: break the topic two or more main blocks, identify relevant keywords, synonyms, abbreviation, wildcard terms for each. So just I copy this prompt and I ask ChatGPT. So it will give the basic keywords. Here, remember, I'm not teaching you the fundamentals of bibliometric analysis. Here, our focus is on finding research gaps. Here, it gives some of the blocks, right? Keywords, variants for carbon accounting. For block B, technology transformation, and here blockchain technology, right? Here, it gives us Scopus query, search query, right? We just copy and paste this. So and you blindly don't copy and paste. You just if copy and don't paste in Scopus query. We have to verify that AI is not your partner. AI is your research assistant. You have to supervise. Here we have to check. We have to check all whether it's correct or not, right? You have to apply your knowledge. So here, so this is my refined one. So I copy this, and here I have the Scopus, and here we go to the advanced research document, advanced thing, and here type, just paste it, right? You paste it, then we will have how many documents here? 1372, right? First you have to take a note, right? First I apply these keywords in the advanced query in the Scopus. So I got 1000 372 documents. We have to take a note on this, right? It consists of many, right? So when we look at this, right here, uh, when you look at the subject area, environmental science, computer science, engineering, business management, accounting, social science, it's very large, right? We are not going to consider everything, all results, all papers. We just limit our our subject area. My area is business management, accounting, plus you see finance, economic, econometrics, and finance. So I include only inclusion criteria, right? This is inclusion criteria. We only include business management, accounting, and econometrics, and finance. Limited. Then how many? There are 438 documents. There are right documents, and then you see author. There are 6 authors unidentified. We don't no author name. And here there are a lot of document types. Document type here: article 293 articles, book chapter 69, review papers, conference paper, books, conference. Right? We have to provide the concrete evidence. So therefore, we have to collect data from reliable sources. Here, article and reviews most commonly use this. So our research limit, we exclude book chapters, conference papers, books, conference review, right? Then we limit our research into article and review. Now it's become 322. 322 documents. Again, here we can consider both final paper and article on press and journal, no issue, and keyword. Here now when you look at the keywords which are more suitable for us, and we don't worry about the country, journal. Here language we are going to deal with. We can't read German, Polish, Chinese, Italian. We can't read. So our research limit our language is English. Then how many? 315. So I'm going to work out on this 315. So we have to record all the steps, and we have to prepare the prisma diagram, right? We have to take each and every note. Each and every task has to be noted precisely. And then I'm going to download this data sets. So click all, and we export the data. Better have a CSV file. What information I need? This here: citation informations, bibliometric information, affiliation, identify, PubMed, publisher, right? We know, and very careful. Here we need abstract and keywords. Without these abstract and keywords, the bibliometric analysis will not help us. So these things are optional. We don't want that one. And now I export this. It take a while. So you see at the beginning, so there are millions. Then we select papers, right? Corpus 315. So here 315 papers I've downloaded. So we can open this. Don't convert. You see the author detail here, author details, and author full name. Author has their own Scopus ID, and the ID is here, and title of the paper, and published year, and the source title mean it's what journal name. Journal name. Journal name and volume, issue, article number, starting page, ending page, cited, how many citation. This is very important, right? Citation. A paper is getting higher number of citation is impeccable paper. The citation, right? Citation gives the clue, evidence for finding the uh, impact. Seminal paper. So DOI number also given you. The labeling of the paper in the scopus, affiliation of the paper, authors, affiliation, abstract. You see abstract for all papers. You see abstract, yeah, abstract, right? Abstract. Author's keyword, indexing keyword, corresponding author address, editor of the journal, publisher, ISSN number, and here very important one is citation. Citers. Here, citation. So something missing, right? Something missing. For the file size, only 990 KB. So it's missing, right? It's missing. Again, I download cited references. Here, cited reference is very important. Right, right. Then I have already downloaded that one. This is easy, 4 MB, almost 5 megabytes. So I will use this one similar to this, right? Similar to this. So I will use in their Biblioshiny. Right. Now I start Biblioshiny. Here I order this is Biblioshiny. I stop this. So this is the Biblioshiny, and we will import this one. Import this one. Import the data. So I downloaded the data from here. I'm going to import the raw data file. It is downloaded from Scopus, and we locate the paper. This is the paper, and click start. You see, it will give us full detail of the paper. We can trace it. We can trace what the data is missing. So mostly here web of science categories are missing. It is not no need for analysis. And the cited references, yeah, in earlier file it was missing cited references. Now it's right, all article having cited references. Without cited references we can't run bibliometric coupling or citation analysis, co-citation analysis. We can't run, right? So data is given, and here, right, here this option you can use to merge files. If you collect data from web of science and Scopus, you can use this option to merge. And reference matching. Here, reference matching, I told you, we have to do cleaning, data cleaning. Some author names are missing, or some one author name appears in two different styles, that thing. So first we use the machines algorithms. For this algorithm is good inbuilt in their Biblioshiny, so that we can use this. And Jaro Winkler method is more recommended. If I run, it's take little time, right? Little time, and it's run it. So small number of data set. And when you look at the R Studio, it start processing. Here generating affiliation field author CN is done. Right, it's working. It's working. So meanwhile, right, meanwhile in the Biblioshiny, it has AI feature. It has AI feature. You can see the info, and you can see here Biblio AI. It processing, right? It takes time. Biblio AI. So Biblioshiny now integrated with AI, especially Google Gemini. We have to connect. We have to connect these Biblioshiny with Google AI Gemini, right? Google's Gemini. Then how we set up? Here go to setting. Go to setting. So it's processing. It takes time. Wait. It's take time. So it's running, right? Cleaning. Start cleaning. So before that, you have to open, right? Open your Gemini account, right? Google Studio. You have to go to Google Studio, and here API. You have to create an API. Get API key, and here create API key, and you create a project. Say or Biblioshiny or something, right? And create a project. It will give you API key. Here it's loading. Here create API key. It will give you a new API key, right? You can copy this API key and copy, right? Copy this API key, and you can paste. You can paste here in the API setting. Here, if we click this, and it will ask API, so we can paste that API. Then this Biblioshiny is automatically integrated with AI Gemini, so that we don't want to copy and paste the prompt all the times. If you are unable to interpret the outputs given by this analysis, this Biblioshiny, right, you can get the AI help integrated. You don't want to copy and paste. So hard things can be made easier. It's running, it's detected. Yes, case 1.5 normalizing journal's name, right? The journal's name, so it may have different name. Here, for example, dirty data. So what the current process actually what doing is, here one paper, Smith J. Carbon accounting, right? The same, right? Smith J. A. Carbon account 2020 Journal of Cleaner Production. Here the Journal of Cleaner Production, right? It gives different name, but all these thing has to be merged together, right? All here 1 2 3 4 5, all 5 denote one paper, but here gives it 5 times. So we have to normalize them, and we have to instruct the software these 5 different names referring one. So this is how we have to do some cleaning. That part is going on here, right? It's done. You see now, you see, after cleaning, earlier we had 21,130 original citation. Now it has removed, it cleaned. Now it found the origin unique citations after removing the duplicates 1950, almost 10% of the data has merged. So you think to process this 21,000 data, friends, how many hours we need doing it manually, right? So it's very hard. So this is automation process. The algorithm works behind, machine learning works behind, and then we have to do it manually. So we just take top 1% of the papers, top 1% of the authors. Now its data is got cleaned. Now we have to click this button, apply normalized citations. Right now this clean data set is get ready for the analysis. And here Biblio AI, now here when I click setting, it's look like this. And here I paste my API key here. I already pasted my API key and set API key, then it's worked. Now we normally use Gemini 2.5 and token output. So that's fine. That's the only way, only thing you have to do. Generate API, Gemini API key, and paste it. And now the Biblioshiny is integrated with Gemini. Now, as I told you earlier, we have to draw a Prisma diagram. Before that, here, screening. Look at here, there are 313 articles after cleaning, and it gives some of the details. The range, publication year, range from 1996 to 2026. And let's see the overview, main information. You see, the time span is give the summary, the table, right? It's the same thing in table form. And when we see the scientific production over time, so from 1996 to 2026, now we are in the middle of this 2026. So that's why it looks going down, but actually not. Here 2025 it got published 100, there are 195 papers, but here into 1996, yeah, all this year no papers. 1996 only one. After that there is no papers. Here no paper again. Start 2019. Only 2019 onwards there are papers. So therefore we don't want this area. We don't want. So therefore I filter it. We don't want. So I make it 2019 onwards. Then I got apply. You see already there are 313 papers. Now it's 312 papers. Only one paper missing. Right? If you are not like to have a review paper, then we can just get delete. And you see how many journal articles here, 283. But our scope including what? Review paper, we include that as well. So apply 312 papers. Now after that we have to prepare a Prisma diagram. Here how we calculate, how we prepare it. Here we are taking from Scopus. What search query, what is our search query or topic. So we have different three topics, say carbon, right? For example, carbon, how many records we got earlier, 1346 or something. And we didn't ask it, we didn't get anything like Web of Science or Scopus. So if we example Web of Science record, say we record 200 record for example, then generate Prisma diagram. It will generate and we get some of the steps. So if we remove duplicates, say 200 duplicates removed, then generate here, it will generate prisma diagram, right? And
Yeah, sorry to interrupt, sir.
yes, please.
Sir, your voice is not audible, sir, not clear.
um, so totally it's working, maybe the network issue. It's,
Okay, sir.
it's okay. Is it totally muted? Oh,
No, sir, audible.
so others, is it clear for everybody? The audio is problem.
It's getting interrupted.
So I think network issue. Mm. Okay, I do my best.
Yes,
Uh,
I can hear you. Your voice is good.
okay, then the problem with your side network. So my side is okay because somebody able to hear clearly. Okay. Um, so right now we can here work on this. Right now we look at the main information again. Yeah, it's updated. Earlier it was to the 1996. Now automatically updated. Now, now the users got confused. How do we interpret this? So here you can see a button, Biblio AI, Biblio AI inbuilt, and here's a prompt. The analysis was performed on collaboration collection download from following uh, bibliometric databases. Here we get data only from this corpus now. Then so this is a prompt. If you get in from multiple data source, it will automatically adjust it. Now I click ask AI. It's connect to the Gemini, and it's thinking. Now AI is thinking, and it will give us how do we interpret this. So it's thinking. Right? AI Gemini is thinking, and it will give us an interpretation. Here, hello, as Biblio AI, I'm here to help you to interpret the statistic. And here, this is the interpretation of your bibliometric collection statistics. This collection sourced corpus represent a relatively focused but highly dynamic research area. The time span, here the interpretation, document, and sources here, and keyword, everything, right? Very nicely interpreted, precisely interpreted. Influences, right? So what we have to do is just copy this, just copy, or you just save this output. For example, this is here Biblio AI information. You can save, or we can just copy and paste. Copy, right? Just copy and paste your Word document, and it's fine. And here earlier it was 2023, right? Here from 23 onwards. Earlier it was 1996, and average citation per year. So I'm not going to tell all of these things because those are fundamentals you might studied earlier. Those are things, and here this is overview, and now the sources. Now we have to find what is the most relevant source, what is the most relevant article in this area, in this domain. You see the Journal of Cleaner Production, it publishes 30 papers. Corporate social responsibility and environmental account, here 16 papers. Business strategy and the environment, 11 papers. Likewise you can get the output here. The journal, and here if you want you can save it in the Excel. If you click it, it will save in Excel. And the most local cited sources, citations, not publication, sources, which document got more citations? Here, 49, 47. You see this one, this author, this paper, right, got citation 49. And Bradford Law, as I already explained you, Bradford Law. So what are the core journals, what are the peripheral journals? If you don't know how to explain this, how to interpret this graph, here you can see Biblio AI. Just click here, already prompt is generated, automatically generated prompt. You don't want to enter anything. If you adjust anything here, if you adjust it, it will automatically adjust there. Everything is here. Then just ask Biblio AI, it will interpret you. You see, it will think, it is thinking now. It is thinking. Likewise, here the source embed, then you can find who is the main author, right? Most relevant author. You see, most relevant author. Liu X, he's published 3 papers. Li Y published 6 papers. Likewise, we can see the record here. The article fractionalized mean the Liu has published 7 papers, but he has collaborated with other authors. So the number of publication is divided by number of authors in each works combined. Then the article fractionalized is counted. If he publish papers with as a single author, he will get more score here. And most local cited author, DIJ, has published papers but got 12 citations. 12 citations. Kaspa P got 11 citations. You see, I already asked the Gemini to interpret this graph. You see, degree of concentration versus dispersion in the field publication landscape. The analysis reveals moderate degree of concentration in the research field. Bradford's law persists that a small number of core journals account for a significant portion. Well, likewise, the AI helps you to interpret not only this plot, this table, right? This table, the summary, Bradford or summary, right? Everything is included there, and it's start interpreting, right? And you see the author, and you see the Lotka's law. It also gives us a precise measure of productivity of authors. Lotka's law. It generate what is that? The plot first. And it takes time. It's processing behind it's processing, right? Even though I have GPU in my laptop, it takes time because the data set is not much larger, but we have clean data, lot of cited references, so it takes time. So likewise, we can do many analysis. Here this overview section, we did right, annual production, average citation, life cycle, and the sources. Sources mean the journal. What is the most relevant journal? What is most cited journal? What are the core journals? What are the peripheral journals? Which journal has more impact? Right? Which journals produces articles from which year to which year? Like that. So it takes a lot of time. And if you want to measure uh, about the authors, you see we can run author profile, relevant authors, local authors. So it takes time to making plot. The summary is given. I already plotted here, and you see most relevant author, right? Everything is done, and author's local impact. Author impact is given. The Lee Y, his H index, G index, M index, total citations, number of publication, the publication year started when he start publication, everything is given, and how authors are work. Here, sorry, this is about the affiliations. Southwestern University of Finance and Economics published many papers in this domain, and here publication, authors publication over time. Here Liu X, he has started publication in 2023 and published two articles, and then two articles in 2024, two articles 2025, and one article in 2026. He worked since 2023. But Kumar, most probably an Indian author, he has published one in 2021, and he get a gap, long period of gap, and 2024 he has published two, and citation 19.33, like that, and also recently got published. If you want to get more information about Kumar, here you can see author profile, and just click Kumar, which Kumar A. There are a lot of Kumars. Kumar A, and click it, so it will give the author details. So it's getting from API, right? He knows it. He is from London Metropolitan University. Anil Kumar, the last year publication, right? So the profile is not yet updated properly, and global profile. And here he did 4 publication. He has 141 citations. His index is 3, citation per year 11.4, like that. Likewise, we can see his impact, and also which countries produced more. Here China leading. It has publishes how many? 66 papers. Out of this, 80 papers are a multi-country publication, and 66 uh, in a single country publication, China only. You see India, right? But comparatively, India has less multi-country publications, only 3, and 15 India only, authors only coming from India, right? So when you see the table, India totally 18 articles, single country publication 15, multi-country publication 3. So India performed well. So if you want to if you want interpretation uh, using Gemini, you can ask here by clicking this. You can ask. Likewise, you can get more. And most cited countries citation, even though by the China leading again, India 84, right? In the publication side, India rank 2, but citation wise, India goes 10th rank. So Indians publish papers, but no, most of the papers are not much impacted. Impact papers just published, not no, it does not get more citations. Right. So there are a lot of things we can see, and the most relevant paper, most cited document in this area, Asif, right? Asif technology forecast social change. This is this paper is more influential paper. It got many citations, 226 and 50.5 citation per year. If you want to get this paper, just click this. It will go to the relevant website. So it will show you the paper. Right? This is the paper. Right? If you subscribed, you can download the paper, or you can purchase the paper. So it's directly, easily, right? We don't want to search the paper in Google Scholar in Google, so it give us the paper automatically, right, by clicking it. So there are a lot of things, but our focus is on finding the search gap, our core. So what we have to do is we have to go to the thematic map, right? We have to go thematic map, and we click here. It will give us some of the there are 4 quadrants, right? This is niche theme and the emerging, and here are motor themes and basic themes, right? Dr. Premilata, can I get more time than scheduled? Can I take more 10 or 15 minutes? Is it allowable?
Yes, sir, you can.
Yes, sir.
Yes, sir.
Okay, thank you for granting permission. So that's a core, right? Without discussing this thing, the entire seminar is useless, right? Now you see, it generated. You look at here, machine learning and machine learning. Why is that? So by just doing this thing, right? Uh, if we use this thematic map in our analysis, it misleads. Your supervisor will throw your proposal in your face. Journal editor will desk reject without any excuse. Why? We didn't do a proper analysis. We just update the paper, upload the paper, do the cleaning, and do the data analysis. But here, machine learning dash. You see here, machine learning. So though both are same, no, same. Why this? Why it's happening? We have to do, right? No, thesaurus, right? Thesaurus. So synonyms, similar words. So machine learning may be in different forms, right? We have to prepare a table, clean table, so that we can use AI. So due to this time limitation, I have already developed this thing, right? Thesaurus. Here, artificial intelligence, you see, artificial intelligence with dash. Here I clean. This is the, it should be replaced, this word should be replaced by this. Some authors like this, artificial intelligence, and also it's referring this AI, AI, machine learning. You should be read it as a machine learning. Sometimes ML, it's machine learning. Deep learning, here dash, referring deep learning. Likewise, we have to prepare a thesaurus, right? Thesaurus, so that we can have, right, data cleaning and thesaurus. We say I have written a prompt to generate thesaurus. I am conducting bibliometric analysis. So into the topic, I have collected bibliometric data using keywords. Then, right. So this way we have to write this prompt, and the AI will give us correct thesaurus, right? And now what I'm going to do is before, right? So we have to do the thesaurus now. We have, before that, what we have to do, we have to go to the core network analysis and co-occurrence analysis. So yes, before that, here most frequent words, we have to go to the most frequent words of the documents and click here. It will give us the words. There are 1686 keywords, right? So we don't want everything, so I just choose 150 top 150 words. I choose 150 top words, then I click, and you see we can get the data file, right? These are the words. And if we click the Excel, the right, the most frequent words will be displayed here. This is the most frequent words. So here ESG displayed 57 times, sustainability 42 times, like that. I take all these words up to how many? So there are how many words? There are 1687 words. So that I take that thing, I take the top 140 words almost, and I do, right, I do thesaurus synonyms. Then I upload. I prepared the synonym thesaurus, and then I upload this. And how do I upload? Click here and edit, text editing, and here list of synonyms. Then I upload synonyms. So this is my synonyms, right here. It's displayed here. And then some words I want to remove, right? Say I already prepared that as well. So what words has not to be considered here? China, literature review, performance, regression analysis, system literature review, commerce, article, bibliometric. So these word also included many times in their uh, papers. So these words should not be considered. These are generic words. So we have to remove them. So that I have prepared the list in the text file. Also, I upload that file as well. Here, uh, here, load a list of terms to remove. Yes, I have. Then, so this is the remove words thematic analysis. Yeah, right here, these are the words I want to remove this. Okay, and click again. So it will give us, now got changed. The top word is what? Earlier ESG, now environmental social governance, machine learning, sustainability, likewise, right? Now we got clean data set. Now it's ready. Now we can prepare word cloud as well. You see word cloud. Now let's word cloud, and we move to the thematic map, and I upload again. Yes, what words to remove, and here synonyms. Yes, I have synonyms. Now you see machine learning occurs two times now earlier. Now it has removed, right? Those two words now combined as counted as one word. And right, then there are some overlaps, the niche theme, And the motor themes, here we couldn't find any basic themes, and many themes in their clusters in their emerging or declining theme. So we have to do some refinement. So what I do is, here I adjust to 320 roughly, and yes, it's almost fine now, right? Now it's almost fine. Here the niche themes, there are some words, keywords, and here we can see, right? If we want to interpret this, we can go to the Bib AI and we can ask, it will interpret as we did earlier. But now we are going to use we are going to use this as input to the ChatGPT, right? So here we can have network diagrams, a table, right? The network table is now here. This network table can, right, we just download the thematic words, right? Download this, and cluster, download this, and the documents, there's a table, and download this, plus network table, the map also here. If I click this, it will save in our file, thematic map. So there are four files we have downloaded, right? And I go back to the slide. The diagnostic lens, decoding the thematic map. Here there are four quadrants, as you see here, four quadrants: niche theme, emerging, and motor, basic themes. This relevance or centrality, how does the degree of connectedness with others here? But here the density means a development. So this quadrant indicates that it has more centrality. It has connected with many papers, many documents, but the development is not sufficient. Carbon emission, blockchain, carbon footprinting in one cluster not developed much, and environmental, social, governance, sustainability, machine learning, right? It has basic themes, right? So this theme is right, it has a lot of connections with other discipline researchers, and even in our research area, but not sufficiently matured. So there's a research gap. We can find research gap number one, maturity gap. This is called what? You see, maturity gap, the high centrality, low density, it is what? Maturity gap, central and important, but structurally underdeveloped, right? So that's kind of research gap. It's a kind of research gap. We lock that research gap in that quadrant, that is called maturity gap. Second one, we look at here niche theme. When you look at this, we can see big data, learning system, energy efficiency, right? So these are niche themes. Here it's mean it has not connected with many papers. Those are isolated things, right? But it has developed. You see this one, density, high density, but low centrality. It does not. It developed internally, but has no many connections. Isolated one. So this kind of gap is called integration gap. This gap is called what? Integration. We have to integrate this kind of themes, this kind of topics with motor themes or basic themes. So we can connect big data to carbon emission. We can connect learning system, right, with the blockchain, carbon footprinting. Right? integration. We have to, if we want to work out in this area, right, we have to work out with other topics. So integration, right, integration gap. The third one, right, this motor themes, it is highly developed and highly centrality, highly uh, relevance. So well developed and well connected. If we find research gap in this area, if we are working on that area, the authors already discussed, saturated this area. To find a research gap is very hard. If you want to publish here, the journal editors may look at this. This is mostly, right, this is almost already researched area. So finding the gap is very hard. It's matured, but it requires some of the refinement. We can do some improvement area, right? It's called refinement gap. Area is mature but needs methodological, contextual. You can introduce new way of analyzing the data. You may introduce a new methodology. You can test in other context, like this kind of research has done in China, USA, and India is a different context, so we can do in India with, and we are going to use a different method, not the same method. Uh, we are going to do some innovation, right, novelty. So you have to satisfy. It's a risky area, and most of the times the people are not work here. Already worked, saturated, well developed, well connected, well published. The fourth one, right, emerging. Now the area is got emerged, and sometime, so the area is just emerged. There are we have no guarantee that this area will sustain for long period. So ESG report, sustainable accounting, low emission, right? These areas just emerge. Now it's an emerging topic. Sometimes decline without sustain. It's called what? Emerging, declining, emerging opportunities gap. So weakly developed, new frontiers if backed by recent data, right? So there are four. This is how we interpret thematic map to find the research gap. This is the foundation. That is not enough, right? It is not enough. Then we have to move to the VOSviewer here. This is VOSviewer. Now I'm going to do, right, keyword co-occurrence analysis, bibliometric coupling analysis, co-citation analysis. What it measure? Current visibility, connectivity. Here what we are going to test here: occurrences, number of times, the total link strength, average publication years. So what's the rule? Proves whether the theme is active, conceptually grouped, or fragmented. Bibliometric coupling, current research front. All right. And co-citation analysis, intellectual foundation. We can find theories here using co-citation analysis. We can see we can see the current research trend, right? Current trend. Here it gives some of the themes, ideas. So this can be done in VOSviewer, not Biblioshiny. Effectively can do in Biblioshiny, but not this much better. So VOSviewer, expert in making network diagram. So first create map with bibliographic data, and I have taken the data from Scopus, and I click Scopus, and it is here. So we just download here, no, 315. It's old one. Right. First we will do co-occurrences of keyword. We will do this one, keyword analysis, keyword co-occurrence. keyword co-occurrence. Here, co-occurrence analysis, we are going to consider keywords, not all the keywords, not index keyword. We are working with all keywords. And here, thesaurus, we want a thesaurus file. So we already developed one. Here, I have seen CSV file. Thesaurus file, right? Excel sheet. Then next, here I make it threshold is 70. If you feel this is much more, we can increase it. So we'll make it 5. So there are 1657 keywords. Out of this, we will select 70 papers that meet the threshold. It occurs at least a keyword that occurs 5 times. That satisfy how many papers? 70 papers satisfy this criteria. And these are the keywords. These are the top 70 keywords. It gets maximum at least 5, minimum 5 keywords. So right, this is the network diagram. You can see there are clusters. So red cluster, blue cluster, right, green, yellow. Some nodes are bigger. So ESG is a bigger, so well developed. You see density, ESG, artificial intelligence, machine learning, greenhouse, sustainability, ESG disclosure. Those are larger nodes. So it has more. The occurrences, number of occurrences is large. The term keyword ESG is connected textual analysis, emerging market, sustainable themes, sustainable reporting, right? Then artificial intelligence, it's connected with these key terms. So what we do is we just export this data as a JSON file, and I'm going to save it here, co-occurrences. So I save this file, right? Next I'm going to do co-citation analysis. Co-citation here, co-citations, and I'm going to do cited references interp analysis. Next, it's too much, for I make it 10. Okay, 10. And right, finish it. Right, so these papers are cited together. So we take this one as well. We take so this is citations, and then we do bibliometric coupling. Bibliometric coupling documents. Okay, yes, we will make it 70. Okay. Uh, 57 threshold. Right, so this is how bibliometric coupling is appears. So we also save this file, coupling. Right, so we did it. We did 3 analyses: a keyword co-occurrence analysis, bibliometric coupling, co-citation analysis. Bibliometric coupling to find the current research trend, and co-citation analysis to find the foundational papers, foundational theories, and relevant theories. My paper also here, no? Yes, this is my paper. My name also appears here. Luckily, thank you. And keyword analysis to find out the such themes. Right, so I can close this. Now next we will right. First target map is quadrant. and we take some evidences from the VOSviewer. So we will take it together, and I have already have prompt. I have written prompt for finding research gap and future directions. Here I copy this prompt and go to ChatGPT, and I paste this here. Before that, I ask ChatGPT what is my research topic. List my research questions. And meanwhile, I download, right? I upload these things. I have right. I save the exported bibliometric coupling, co-citation, and co-occurrences. So I upload here, and from the VOSviewer, right? VOSviewer, I have downloaded this map and network. So not network, table, clusters, documents. I uploaded this as well. If you want, meanwhile, we can run this bibliometry AI. So we can ask. You see the prompt. You see this prompt. It's automatically generated prompt by this Biblioshiny. Now I ask, it will connect to the Google Gemini API AI. Yes, I uploaded, and so these are the bibliometric themes. Not this one. Okay, and I uploaded this as well. Now I copy the prompt. This is my prompt to find out research gap and direction for future research. Evidence. Here, thematic map structure, cluster 1, cluster 2, cluster 3, right? Step by step it will map. Now second stage, VOSviewer. Stage 1, thematic map. Stage 2, VOSviewer, evidence, supporting evidence. So the main area, main techniques to find research gap is thematic map, maturity gap, refinement gap, integration gap, emerging gap, and we can do some bridging and blind spots. Here, these are the blank areas, no? Blank areas. That also a research gap, right? Here, when we look at the keywords, we can see carbon emission, blockchain, right? ESG. But there are some important words are missing. What are the words? Like scope 1, scope 2, scope 3, and sustainable reporting standard, S2, S1. So these kind of things are missing. So that also blind spot. That also will be investigated by the AI. So here research gaps, right? First one, gap. There are gaps. Fragmented integration of blockchain in carbon accounting system. What's a gap type is maturity gaps. Maturity gaps mean in this quadrant. This quadrant is found thematic evidence, basic theme, carbon emission, blockchain cluster underdeveloped, VOSviewer evidence. Here blockchain, the link, right? 52, but weak coupling with ESG and AI clustering interpretation technology exists, but lack integration into governance framework. Future directions integrate blockchain with ESG reporting. Or the research question in how can blockchain improve carbon accounting transparency? Or what governance mechanics enable blockchain adoption in ESG? So, in academic sentence, the thematic structure suggests that blockchain based carbon accounting remains conceptually fragmented despite it increasing evidence. You see how strongly it's right. Evidence backed, mathematically, scientifically proven research gap. Here, gap number two, it's also coming under maturity gap. Lack of theoretical consolidation in AI driven ESG and sustainability. Such question could be what theoretical model explain AI driven ESG? No foundational theories here. And a weak integration gap. Here, integration gap. Where is it? Integration gap. Here, right? Niche theme. Here, right? Strong evidence. Integrate AI and big data into carbon accounting system. And missing link between governance theories and carbon accounting. Right? Governance and technology research separately. And future direction was combine institutional stakeholder theory with digital carbon system. Likewise, it will give us right research gap, 6 research gaps, and it give us summary research gap and what type of research gap is, and thematic evidences, and VOSviewer support, logic, what is strength of the things, and what is the future directions. Yeah, finally, in a bibliometric paper, we can write research gaps and future directions. It will academically give you the things. Finally, it will give you checklist of evidence. Right. So it asks if you want, turn this introduction to Q1 level discussion. Yes, of course. Yes, it will write. So here, uh, the target map is what? The quadrant, four uh, quadrants, maturity gaps, integration gap, refinement gap, emerging gap, and we support, right? We get evidences more from VOSviewer and we validate it. And also we can give direction for future research. And the strength of research gap. So there are three bars. So only one bar is a tentative research gap. If we have two, it's a moderate strength, and if we have three signals, and it gives very strong, right? Flawless alignment, map positions, robust keyword, and strong bibliometric coupling and co-citation. So best way uh, is to get high 3 bar and high strong research gaps with evidences. Here the maturity gaps and integration gap here, and refinement gap, and emerging and declining gap, and we can connect some of the things, right? And here bridging gaps and blind spots. So this is the mechanism. First we use the bottom layer foundation is what co-citation analysis, and uh, we use bibliometric coupling, and then quadrants thematic map. So we combine the triangle method to find scientifically prove the scientific gaps. So quality control validation check. So when to trust the evidences. So strongly supported. Right? Always use strongly supported evidences for your research papers and these PhD theses. Advanced diagnostics to strengthen finding. Temporal covert analysis again do. Citation burst deduction and manual screening and full text review. Right? Don't stop at this point. Go to the papers, read them, and right, process in your mind, and finally come to the conclusion which research gap is more suitable for your research. So this is the methodology toolkit. So there are four different